All right. So we have got question number one. Uh, and for these first questions, we've already solved this. If you've seen the videos that I've been sending you, question one, question two. Okay. Let u be equal to -7 to 10 be the universal set. You've got set A, set B, and set C be subsets. You want to find A intersection B minus C. So we know that we can as well write this as A intersection B intersection C complement. So when you get to write that, now you are able to see you have got a C complement. So you can write a number line. It will be easier for you, even if they've not asked you to show on a number line. Now start first with the one with a complement. That is C. Now I always mention this. Firstly, make sure that you put your universal set on the number line. The universal set is from -7. We are including -7, so I'll just put a closed circle here up to +10. At +10, I'll also put a closed circle because both -7 and 10 are in the universal set. Now we go to the set C, C starting from -7 up to 6. So 6 is going to be, let's say, somewhere here. Now if you can notice, 6 is not part of the set C, meaning that it will be part of the complement. So I'm going to put a dash here, shade it, then go in this direction. This is going to be C complement. And you also have -7. -7 is not part of the set C, therefore it's going to be part of the complement, since we know that -7 is in the universal set. So that is the dot that you are able to see here. I don't know if this is okay. So this what you're able to see here, starting from the dot -7 and then from 6 to 10, this is C complement. And then now we can get B, the set B. The set B is from -2 to +8. And we are including both -2 and +8. So the intersection is this region which is common that we're able to see. I'm still looking at what I'm writing. It's not yet reflecting on the. Okay, so we are saying the set B is from 1, or that is actually from 1. I wrote another set. This is from +1. Okay, that is from +1 up to +8, and we are including both +1 and +8. So what I've done is I've gotten the intersection of B with C complement. That is the region that you're able to see shaded there. So I've worked out what is in these brackets here. B intersection C complement, that's the shaded region. And then that answer that we get, the shaded region, is supposed to intersect it with the set A. The set A starting from -1, let's say -1 is here. I mean from -2 up to +8. And we are not including both. So it would be from here up to here. So the intersection, we want where this region which I've shaded is intersecting with this line that you're able to see down here. So that is basically from here, from 6 up to 8. But because 8, you can see, is not part of the set A, therefore it will not be part of the intersection. So therefore the intersection is going to be 6, 8. But 8 is not part, 6 is part of the intersection because it is found in both sets. I hope that is okay. Are we good?
Yes.
All right. And then we'll look at C complement. Now C complement, we know that's more direct. So firstly, I'll put the universal set starting from -7 going to +10. I'm going to put two dots here on the universal set. We know that 7 and -7 and +10, they're both in the universal set. Now one C complement, and C is starting from -7 to +6, meaning that the complement, since 6 is not part of C, is going to be part of the complement. And then I'll go this side. And then since -7 is not part of C, meaning that it will be part of the complement. So I'll just put, that will just be -7 like that. Like the universal set starts from -7 and C also starts from the -7. The only difference is that C is not including -7, but the universal set is including -7. So obviously it's going to be part of the what? Of the complement. So this what I've done here is a complement. So we'll say C complement is -7. Now -7 is an element, so you use curly brackets. And then union, you have got from +6 to +10. So that is how it is going to be. I hope it is okay also for this one. So that is how we're able to work this one out. If it is not, please be sure to ask. For the next one, we want A union C complement. Now the first thing that I'm going to do is I'm going to show A union C. Okay, we know that A is starting from -2 to +8. So -2 here, +8 here. We are not including any. And then the set C is starting from -7 to 10. I mean from -7 to 6. And we are also not including n. So the union just get to combine these two sets. So you see that the union is going to start from -7 all the way up to +8. So this is A union C. But what we want is A union C complement. Now the universal set ends up to 10. So the complement will start from here. Since 8 is not part of the union, it will be part of the complement up to 10. And then at also -7 there, okay, we'll also put a dot. So this is A union C complement. So we are saying that A union C complement is -7, use curly brackets, union. Then you have got from 8 to 10. Okay, are we okay with this one? Are we okay? Faith, is it okay?
It's okay.
The next one, we want to express 2 square root of 3 plus 1 over 2 minus square root of 3 in the form a plus b square root of 3. So we're going to rationalize the denominator 2 square root of 3 plus 1 divided by 2 minus square root of 3. Rationalizing the denominator, multiply on top the conjugate of the denominator. So just change the sign on the middle. That is going to be 2 plus square root of 3. Also down 2 plus square root of 3. So start multiplying on top. We have got 2 square root of 3 times 2. That is going to become 4 square root of 3. Just multiply the 2 with the 2 outside. 2 square root of 3 times the square root of 3. That is going to be 2. So multiply the roots together. Root 3 times root 3, that is going to just give you a 3. Because you're supposed to multiply what is inside. Root 3 times root 3, that was supposed to give you root 9. Now root 9, we know that is a 3. And then multiply 1 by 2, that is a 2. and then multiply 1 by root 3, that is a root 3. Divide then by the two denominators, conjugate them. Now, when you multiply a number by its conjugate, just get the first one, square it, minus get the second one, you also square it. This is a difference of two squares. So on top, we have got 2 times the 3, which is a 6. And we can add this 6 plus 2, that is 8. And then we have got 4 root 3 plus root 3, that is going to give us 5 root 3. In the denominator, we have got 2 squared, which is a 4. Root 3 squared, that is a 3. So 4 minus 3, that is a 1. So basically, the answer will just be 8 plus 5 root 3. So that is it. Question number B. B, that is B2. If alpha and beta are the roots of the equation x squared plus 4x minus 2 is equal to 0, find the sum 1 over beta squared plus 1 over alpha squared. Now, first thing first, whenever we've been given the roots of an equation, first find the sum of the roots. So the roots we've been given is alpha and beta. So find their sum, alpha plus beta. We know this is given by negative b over a. So this is going to be negative b, in this case is a 4. A is 1, the number in front of x squared. So it will just be negative 4. And then we find also alpha times beta, which is given by c over a. Okay. C in this case is negative 2 divided by a, which is 1, negative 2 over 1, that's basically negative 2. So we can now go on and find 1 over beta squared plus 1 over alpha squared. This is going to give us, just cross multiply, that is going to be alpha squared plus beta squared, and then divided by alpha squared beta squared, which we can also write as alpha beta squared. And then where we have alpha squared plus beta squared, you need to know if you factorize out alpha squared plus beta squared, you are going to get alpha plus beta squared minus 2 alpha beta, and then divided by alpha beta squared. Please, you need to know whenever you've got alpha squared plus beta squared, that is what you are going to get. So where there is alpha plus beta, we are going to substitute negative 4. So that will be negative 4 squared minus 2. Where there is alpha beta, we know alpha beta is negative 2 also. And then divided by alpha beta again. Okay. So alpha beta, that is still negative 2. That is what we're going to put down there. That is to be negative 2 squared. Just a moment, I connect this thing to the... Alright, so that is going to be negative 2 squared. Then just get to simplify 4 squared. Negative 4 squared is 16. Negative 2 times negative 2 is positive 4. 16 plus 4, that is a 20. Negative 2 squared is a 4. That is going to give us a 5. So this is the sum of the roots 1 over alpha squared plus 1 over beta squared. We'll go to the next one. Solve the inequality x over x minus 3 is greater than or equal to 1 over 2. X over x minus 3 greater than or equal to 1 over 2. Now friends, when you are talking about inequalities, you don't cross multiply. So what I'm going to do is I'm going to take the 1 over 2 to the other side of the equation to be x divided by x minus 3 becomes minus 1 over 2 greater than or equal to 0. Okay, from here now we are going to merge as a single fraction. Now multiply what's on top of the first fraction with what is on the bottom of the second fraction. So that will give us 2x. And then negative 1 on top of the second fraction, I'll multiply with the x minus 3. That will be negative x plus 3. Then multiply the two denominators. We are going to have 2x minus 6. And this is going to be greater than or equal to 0. Simplified, we are going to have x plus 3 over. Now down, I'll still factorize out an x. So we're going to have x minus 3. I'll factorize out a 2 greater than or equal to 0. When you reach at this point, equate what is on top to 0 and also what is on the bottom to 0. So on top, if you equate to 0, you're going to find that x is equal to negative 3. Down, if you equate to 0, you're going to find that x is equal to positive 3. Okay? When we find these two values, I'm going to now put them on a number line, negative 3 and then positive 3. I'm going to also write the factors which are equated to 0 for me to get these values. The first one, x minus 3, also x plus 3. Now when you equated x minus 3 to 0, x minus 3 to 0, we found a positive 3. Meaning that if I use any value above a positive 3, I put here like 4 minus 3 to give me a positive value. Meaning that immediately across the 3, I'm going to get negative values. When we equated x plus 3 to 0, we found negative 3. If I use any value above negative 3, for example, a negative 2, negative 2 plus 3, that will give me a positive value. Immediately across the negative 3, for example, negative 4 plus 3, that will give me a negative value. Now these two values are dividing, or these two factors are dividing. So negative over negative is positive, positive, negative, negative, positive, positive is positive. So we want a region where our function is going to be greater than or equal to 0, meaning that it should be positive. So we're supposed to start from this point, going in this direction where it's positive, and then also starting from here, going in this direction. Now notice that when we equated this one, which is on top, to 0, we found negative 3. But remember, it is greater than or equal to. So negative 3 is going to be included because it's greater than or equal to. Now positive 3, even if the question is saying greater than or equal to, positive 3 will not be included. Why? Because it's in the denominator. The denominator should never be equal to 0. So that is why it's going to be open. Therefore, the meaning of this, the solution set, SS, solution set, is going to be from negative infinity to negative 3. Negative 3 is being included, infinity is never included, and then union from positive 3 to positive infinity. So this is going to be the solution set for this problem. Please, if there is a question, be sure to ask. So negative 3 is being included because the question is saying greater than or equal to. So because of the equal to, that's why we're including negative 3. But a positive 3, even if it's greater than or equal to, we're not including it because it's in the denominator. The denominator should never be equal to 0. Question 2. Let 1 plus 3i z is equal to 5 multiplied by 1 plus I. Express z in the form a plus bi, where a and b are rational numbers. What we are going to get this one, I'm going to divide both sides by 1 plus 3i so that I remain with a z. So therefore z is going to be, and also this side I'll multiply 5 times 1 is going to be a 5, and then 5 times I, that is going to be 5i. And then both sides I'll divide by 1 plus 3i because we want to express z. Okay, just a moment, it gets to show what I've written there. So basically what we are doing, if you get to look at this question, you have got 1 plus 3iz. So what we want to make is z subject to the formula. That is why I have divided both sides by 1 plus 3I so that I remain with a z alone. And then the 5 I've multiplied with what is inside there. 5 times 1 it gives us 5. 5 times I it gives us 5I. So that we have what is here. And then from here, since we want z in the form a plus ib, we are going to rationalize or conjugate. So on top we're going to multiply by 1 minus 3I. Even down we're going to multiply by 1 minus 3I. So doing this on top, when we get to multiply on top, 5 times 1, which is a 5, 5 times negative 3I, which is negative 8I, and then 5I times 1, which is a positive 5I, 5I times negative 3I, negative 15I squared. Now for complex numbers, when you're multiplying it by the conjugate, just get the first number, square it, and then get plus, get the second number, the number in front of I, 3, square it. Please, you don't need to put a, if these were sides, I would have put a minus on the middle. So it doesn't matter whether this one is negative or is positive and this one is positive or negative. As long as it's a complex number, I always put a plus on the middle. But if it was a side, I would have put a minus. The reason is simple because if you say I squared, it will always give you a negative 1. Negative 1 times negative, which was supposed to be here for a side, always gives you a positive. Hope that is okay. So from here now get to simplify. We know on top there we've got negative 15I squared. You know I squared is negative 1. So negative 1 times negative 15 gives us positive 15. Okay. All right. Yes. How is it an 8I? This wasn't supposed to be 8I. We multiply 5 times 1. 5 times 3. 5 times 1, it gave us 5. 5 times negative 3, that was supposed to be negative 15. Thank you very much. This is supposed to be negative 15. Hi. Alright, so we are saying negative 15I squared. It will give us positive 15. So this is positive 15. We are going to add to the positive 5. That will give us a 20. The negative 15I plus 5I. Negative 15I plus 5I to be negative 10I. And then you have got a denominator there where you've got I squared plus a 3 squared, which is of course a 10. And then 10 into 22, 10 into 10I, that is I. So this is Z in the form A plus IB. Be free to just open the mic if you've got a question and be able to speak. All right, B or part 2. Express 1.45 repeat in the form A over B, where A and B are integers. Now, friends, for this one, I'll say first, let X be equal to what you've been given. Now, just from what we are able to see here, what is repeating is a 4, 5. But even the first two which have been given is a 4, 5. So this is the same as me just writing 1.45 and then I put a dash on top of the 4, 5. Why? Like 4, 5 and 4, 5 repeat. What's the difference? If I say 1, 1, 1, I put a dash here. It is just the same as me saying 1, 1, I put a dash, or me just saying 1, I put a dash. Because when 11 is repeating or when 1 is repeating, it's just the same thing. When 4, 5 is repeating and then you've got a 4, 5 in front, that's just the same thing. Okay? So what I'm saying here is instead of me writing 1.45 and then I write another 45 which is repeating, I'm just going to say 1.45 and then I put a dash on top. Why? Because the 45 is the same as the 45s which are repeating. So that will just simplify your work. Otherwise, if you don't do this, you are going to be getting very big numbers as you are going to be expressing in form of a fraction. Okay, so from here, this is going to be my equation 1. This equation 1, I'm going to multiply it. I want to take the decimal point behind the number that is repeating. So multiply equation 1 by 100. So x times 100, that is 100x. 1.45 times 100, that will just be 145. I'll put a point and then just put 45 just to make sure that the numbers after the decimal are the same in the two equations. And then from here, I'm going to subtract the two equations. So subtract 2 minus 1. So equation 2, I'll write here 100x is equal to 145.45. And then equation 1x is equal to 1.45. Okay, so 100x minus x, that is going to be 99x. And then the other side, 145.45 minus 1.45. Now when you get to subtract that, you can see we have got the 45 after the decimal point which are repeating. So in both equations, after the decimal point, we have got a 0.45. So those two are going to be able to cancel out. Okay, those are going to be able to cancel out. So we are just going to more remain like with 145 minus 1. 145 minus 1, that would basically just give you 144. So I'm waiting for it to move because I can see you are not able to see that I've written something new. All right, it's now shown. So 145.45 minus 1.45, we've said that is going to give us 144. And then divide both sides by 99. So x is going to be 144 divided by 99. We know that 144 is 12 multiplied by 12. So I just want it to be much simple so that you can see a number that can go into 144 and into 99 without leaving any remainder. So obviously that should be a 3. Because we know that 3 can go into 12, that is 4 times. And we know 144 is the same as 12 times 12. So 3 into 12, that is 4. 3 into another 12, that is 4. So that will be 4 times 4, which is this. It is 16. And then 3 into 99, that should be, no, that will not be that will not be F16. So let's say 12 by 12. It's been long I did the multiplication table, so I've also forgotten. This is 4. This is 2. This is 2. Okay, that is 144. Yes. Okay, so let's say 3 into 14. Can 3 go into 14? It will go there 4 times, remainder 2. Since we know that it can go there into 2 or 4 times. So a remainder of 2 is going to remain. And then 3 into 24, is it 8 times? Okay, and then divided by 3 into 99, that is going to be a 33. So I think this is the simplest form that we can leave it, 48 divided by 33. Okay, let me pause a moment and see if there's any question. Are we okay? Joseph, are we okay? Josephine, Faith, and others were in class.
Okay. Okay.
So these are the questions we need to make sure that like you get it all instead of you losing marks. All right. B, prove the identity 1 minus cos 2a plus sin 2a divided by 1 plus cos 2a plus sin 2a to be equal to tan a. Faith, which side did you prove if it came for you? The left hand side or the right hand side?
I think they do too.
Okay, so we're going to get the left hand side. That's the one which is more complex. So on the left hand side, we've got 1 minus cos 2a. Now we also need to know double angle formulas for these. Cos 2a, sin 2a. We need to know that. So I'm going to say left hand side is equal to, we have got 1 minus cos 2a. Anyone who knows any identity for cos, like cos, any identity that you know, cos 2a, I mean the double angle identity for cos 2a. Anyone? I hope you are able to get me. I'm asking anyone who knows double angle identity for cos 2a. Any double angle identity that you know for cos 2a. First, do you know any? Josephine, do you know any?
I'm trying to remember.
Okay. Are you guys able to get me clearly or is my voice cutting? Are you able to get me clearly?
Okay. I think cos 2a is equal to 2 cos squared a minus 1.
Alright. So the simplest we should know is we know that cos 2a is the same as cos a plus a. And that is going to give us cos squared a minus sin squared a. I think that is one thing that you should be able to know. So this I'm going to write it as 1 minus, where there's cos 2a, I'm going to write cos squared a, okay, minus sin squared a. And then we are going to say plus. Now sin 2a, we need to know for sin 2a, friends, we need to know that it is equal to 2 sin a cos a. And then in the denominator, we have got also 1 plus cos 2a, which is cos squared a minus sin squared a. And then you also have sin 2a, which is 2 sin a cos a. So from here, What are we going to express this into? Okay, I can express everything in terms of sin. So that means where there is cos on top there, I'm going to put a sin where there is cos. Like here, where there is cos squared, I'm going to put a sin. And you know what cos squared means, right? It means 1 minus sin squared. So what we're going to have is 1 minus. So if I put 1 minus sin squared and then we have got another minus sin squared, we're going to have 1 minus 2 sin squared a. This is the identity for cos 2a. Then plus 2 sin a cos a. Also in the denominator, we have got 1 plus, I also put the same minus 2 sin squared a, then plus 2 sin a cos a. I multiply by the negative we're able to see. So this 1 and this negative 1, what will happen? They'll cancel out, right? So we're going to remain with it. And then if I multiply this negative with the 1, it will be negative 1, which will cancel with the 1 outside here. And then this negative I multiply by this, it will be positive. So that will be positive 2 sin squared a, and then plus 2 sin a cos a. And then divide down. We are going to have 1 plus 1, which is going to give us a 2, and then minus. We are going to have 2 sin squared a, then plus. We have got again 2 sin a cos a. Okay, I hope that is clear. Well, we need to think of what to do from this point here. Now, if you are able to see, we have got, is the route that I've taken okay? Is it going to take us anywhere here? Okay, if you check the one which is on top, we're able to factorize out a sin, but the denominator we can't factorize out because we've got a constant too. So instead of me expressing the denominator in terms of sin, so you see, like the denominator you can't factorize out here. So what I'm going to do for the denominator, instead of me expressing it in the form 1 minus 2 sin squared, I'm going to express it into 2 cos squared minus 1. So I hope this is not going to be confusing to you guys. Like cos 2a is the same as 1 minus 2 sin squared or 2 cos squared minus 1. So this 1 and this negative 1, they'll cancel out. So we'll just remain with 2 cos squared a. I even left out a here. Then plus 2 sin a cos a. So from here on top, we can factorize out a 2 sin, right? Because a 2 sin is common on top. That is going to be 2 sin a, open brackets. We're going to remain with 1 sin a, and then plus c cos a. And then on the next one there, what is common on the other bracket? We have got a 2 here, we've got a 2 here, we've got a cos here, we've got also a cos. So we're going to factorize out 2 cos. And then what will remain in the first bracket is cos a. What will remain in the next? Sin a. Now we know that addition is commutative, meaning that this thing is the same as this thing. They'll be able to cancel out. And then a 2 is the same as a 2, it will cancel out. So what we've remained with is a sin a over cos a. Faith, what is sin a over cos a? Faith, sin a over cos a. Matilda, what is sin a over cos a? You guys, are you able to get me or not?
It's okay.
Hence shown. Is this okay? I don't know if this is fine. Where?
I think it's fine. Sorry.
All right. You know that your exam is going to be very easy, like for you guys. That is just the courage that I've given you because you've been with us and we have done all we could. That's why I'm saying it is going to be very easy. Let f of x be negative 2x squared plus 11x minus 15. Find the maximum or the minimum point of f of x. Hence, sketch the graph. Want to find the maximum or the minimum. Now, to find the maximum or the minimum, for here, we're supposed to use completing the squares. But you can use a simple formula to find the x value. Just say x is equal to negative b over 2a. So I know that the x value of the turning point is going to be 11 over 4. And then the y value, just that 11 over 4 that I found, put where there is x to find the y value. Or you can say y is equal to 4ac minus b squared over 4a. Now the best here, because most of the questions are going to first come to say complete the squares. So we're going to do the completing of squares. Now when you are completing the squares, first thing first, factorize out. Make sure that the number in front of x squared is a 1. So this is going to be negative 2. I'll factorize out to remain with x squared. Now factorize out only the first two. So even here, if I remove a negative 2, I'm going to remain with negative 11x over 2. And then I've got a negative 15. So that if I multiply back negative 2 times negative 11x over 2, we'll get 11x. Okay. And then from here, I want to write this negative 2. I'll put a bigger bracket. Then a smaller one inside. Instead of writing x squared, I'll just write x minus. I'll get the half of 11 over 2. Just multiply the denominator by 2. That will be the half. That will be 11 over 4. I'll not put x. I'll close. And then I'll put a square. Always subtract here. Always subtract. I'll get whatsoever is here. 11 over 4. Square it. Whatsoever would have been there. We square it. 11 squared is 121. 4 squared is 16. And then I'll close. And then I'll write negative 15 at the end. What I've done here is I've completed the squares. What just remains is to simplify. So this is going to give us negative 2 multiplied by the first bracket. We're going to have negative 2x minus 11 over 4 squared. And then negative 2 times negative 121 over 16. That would be positive 121 over 8. And then minus 15. This will give us negative 2 x minus 11 over 4 squared 121 over 8 minus 15. So multiply 8 times 15. That is 120. So 121 minus 120, that is a 1. And then divided by 8. So what I did is over 1. So 121 times 1 is 121 minus 8 times 15, that is 120. And then multiply the two denominators. So when you're writing the turning point, get what is inside here, change the sign. That will be positive 11 over 4. Comma what is outside, that is the y value 1 over 8. That's how you determine the turning point. And then the next one is saying hence sketch the graph. So for me to be able to sketch the graph, what I should have done, I should also find the x-intercepts and the y-intercept. So for the x-intercepts, I'll just get, if you want, find the product and the sum. You equate it to 0, you find the product and the sum. Now I'm going to get it from here. I'm going to equate it to 0. So I'm going to take also the 1 over 8, the other side of the equation. Okay, since we have equated it to 0. Or instead of me taking the 1 over 8, I'll take the negative 2x minus 11 over 4 squared to the other side. It becomes positive 2x minus 11 over 4 squared is equal to 1 over 8. Divide both sides by 2, so it will be x minus 11 over 4 squared is equal to 1 over 16. Square root both sides, so x is going to be equal to, x minus 11 over 4 is going to be, if we square root 1 over 16, it will be positive 1 over 4, or the same x minus 11 over 4. If we square root, it will be negative 1 over 4. Like if you square root 1 over 16, square root of 1 is 1. Square root of 16 is 4. Now it can either be positive or negative. I'll take the 11 the other side, so x is going to be equal to positive 11 over 4 plus 1 over 4. Yes?
Mm, to get plus positive 121 over 8, did you multiply? Because I heard you say multiply by the negative 2, or did you just divide?
You multiply by negative 2, like 121 multiplied by negative 2. It's more like this 2 here would divide with the 16, it will just give you 8.
Okay.
So if we do the mathematics here, x is going to give us 11 plus 1 over 4, that would be 12 over 4, which is a 3. Or x is going to give us 11 minus 1 is 10. 10 over 4 is the same as 5 over 2. So these are the x values of this is the x-intercept. So right here, the turning point is at 11 over 4, comma 1 over 8. And then the x-intercepts are those. For the y-intercept, you just get this constant. Y-intercept is negative 15. So we can now sketch. The x values we have got positive 3 and positive 5 over 2. Was this supposed to be positive? It is positive. Now I wonder, 5 over 2 positive. Okay, from what I'm able to see, supposed to be positive. Now 5 over 2 is such close, like it is about 2.5. Can you have 3 and 3? Okay, let's see. Let's look at the turning point. The turning point is 11 over 4, comma 1 over 8. Now 11 over 4 is approximately equal to 1 point something. So if this is a 2 here, then this is a 1. Or actually that is an x value. For the y value, it is 1 over 8. 1 over 8 is a number that is very small. It is it's almost near, like it should be much near to 0, because it's going to be smaller than 1 over 2. Okay, so it will be very down. And then the x value is 11 over 4, which is about 1 point something. So if this is,
Above 2.
oh, 4 into 11 is 2, right? Yeah,
Yes.
2 remainder 3. So it's about 2 point something. So if this is a 3, let me say we have got like this, 1 here, 2 here. So it's going to be above 2, somewhere above 2. So the turning point is going to be nearly somewhere here. Okay. And we know where the graph is cutting the y-axis, that is at negative 15. So it's supposed to go like that, and it also goes something like that. So that is how the graph is supposed to go. It's going to pass at 3, and it's going to pass at this point also 5 over 2, which is just about 2 point something also. Now I wonder why it's passing at that point if it wasn't a mistake, but it's supposed to be that. So that is going to be the graph. And we've seen it has got a maximum because this is a negative value. If it was positive, it would have had the minimum. Okay, any question? Any question? I bet that's okay. The table below shows an operation star on set G. G has got elements 1, 5, 7, and 11. Is the operation a binary operation? So if you want to deduce if this operation is a binary operation, look at the set G. It's 1, 5, and 7. So if you get the set G, these are the elements. And then star the set G again. These are the elements. Is the result always part of the set G? So you can see the results, all of them are part of the set G. Like these things we're able to see here, these are the results. So this is a binary operation. What's the reason? Because the result after performing the operation star is always part of the set G. So that's the reason you give. Is the operation commutative? Now when you want to determine commutativity, if I start from here, let's say I say 5 star 7. What's the answer I'm getting? It's 11. Okay. What of if I say 7 star 5? What's the answer I'm getting? Is also 11. So it's the same answer I'm getting whether I start with a 5 star 7 or I start with a 7 star 5. So that means that the operation is commutative. Okay. Hope that is okay. Or if I say 11 star 5, I'm getting a 7. Or I say 5 star 11, I'm getting a 7. So it's all giving the same answer, meaning that the operation is commutative. And then we want to work out 5 star 1 star 11 and 5 star 7 star 11. So let's start with 5 star 1 star 11. So 5 is star 1. It doesn't matter which side you start. If we say 5 star 1 to give us 5, or I can start from this direction 5 star 1, that is still giving us a 5. So it means for this operation we can start in any direction. But for others, they are going to tell you which direction you're going to start from. For example, if you start from this direction, you say star this direction to give you a different answer when you start from this direction, star this direction. So depending with what they've given you, please get to use that. So I've seen that 5 star 1 is a 5, and then we'll go and start with 11. So 5 star 11, that is giving us a 7. So that's the answer. And then we also have 5 star 7 star 7 star 11. So 5 is star 7, 5 there, 7 there. We see that is giving us 11. And then I'll put a star, and then I'll work out this 7 star 11, 7 star 11. We've seen that is giving us a 5. And then now 11 star 5. 11 is here, star 5 is here. It is giving us a 7. So this is the answer. So meaning that this operation, no, I'll not make that conclusion because this and this were different. I wanted to say it's distributive. Okay, for the next one. Let f of x be equal to 2x over 3x minus 2 and g of x be equal to 1 over x squared. State the domain of f and the range of g. So the domain of f, look at the denominator. We know the denominator cannot be equal to 0. So 3x minus 2 should never be equal to 0, meaning that 3x cannot be equal to 2, x cannot be equal to 2 over 3. This is the domain. So say the domain of the function is equal to x is a member of all real numbers such that x is not equal to 2 over 3. Or you can write an interval from negative infinity to 2 over 3, and then from 2 over 3 to positive infinity. So n. Then the next one, the range of g. Here is g. You want the range. So the range of this function, whenever a function is bottom heavy, just know that in the range you're not going to include 0. I mean, not 0, but that should be what? A y value. So because if you get to sketch this function, if you just look at it so quickly, x squared means that x can only be positive, so it's more going to be up. Yeah, that is 0. Or if you want to determine instead of just mastering that, just say y is equal to 1 over x squared. Cross multiply yx squared is equal to 1. Make x up to the formula. So x is equal to 1 over y. Okay. Then make x up the formula. X is going to be square root of 1 over y. So if you saw the way I drew that function, it was like this, up like that. So I'm able to see that the only y values that you can have is only starting from 0 going up, because the denominator is squared. Like you can't have y negative when you're squaring x, you're always squaring x. So the range is from 0 to infinity. You're able to see this one I've written here. So by the reason of this being 1 over, meaning that the denominator cannot be equal to 0. This is one thing you need to take note. By the reason of this being a radical, what is inside should always be positive. That means that 1 over y should always be greater than or equal to 0. But do not say equal to, because the denominator is what? Is a letter. Like it can't be equal to 0. So I'll just say it's greater than 0. Okay. So equate the denominator to 0. We're going to find that y. Like for radical we've always been talking about rational functions when when you're solving the inequalities. You don't cross multiply. So just equate the denominator to 0. We're going to find that it's equal to 0. And then now you look at values that you are going to get, that always give you greater than. So we're going to get what we equated to 0, that is your y, right? The answer that you found was 0. So if I get values of x greater than 0, this is going to be positive. If I get values of x less than, I mean values of y less than 0, I put where there's y, it's going to be negative. We want where it is greater than y. So that means it's only valid for values of x greater than 0. That is why I'm saying is starting from 0 to positive infinity. That's the range. From 0 to positive infinity. You not include 0 because you can't touch. That's an asymptote. Find the composite function f of g of x. So f of g of x, get g, you put in f. So that is going to be equal to 2. Where there is x, I'm going to get 1 over x squared. Then divided by 3. Where there is x, I'll get 1 over x squared. Then minus 2. So this gives us 2 over x squared divided by 3 over x squared minus 2. So I can as well write this as 2 over x squared divided by, made as a single fraction, this is over 1. 3 times 1, that is 3, minus x squared times 2, that is 2x squared divided by x squared. Then from here, this is x squared in the denominator, this is x squared, they'll cancel out. So the answer is just going to be 2 over 3 minus 2x squared. I hope that is okay. So that is f of g of x. Find the inverse of f of x. So the inverse of f of x, let it be equal to y, that is going to be 2x divided by 3x minus 2. Do the cross multiplication. This is going to give us 3yx minus 2y is equal to 2x. Take everything with x the other side. It is going to be 3yx minus 2x, and then the 2y, take it the other side. Factorize out x, so x open brackets 3y minus 2 is equal to 2y. Make x subject. X is going to be 2y divided by 3y minus 2. That means that f inverse of x is going to be 2x divided by 3x minus 2. So I know that is okay for you guys. Then question C. The graph of f of x is equal to 5 plus 2 cos x plus k degrees for 0 is less than or equal to x, which is less than or equal to 360, passes through the point 30 degrees comma 5. Find the smallest value of k. Now you have got a function f of x which is 5 plus 2 cos x plus k. Now it passes through 30 comma 5, meaning that this function is going to be equal to 5 when the angle is 30. So that is going to be 5 plus 2 cos, where there is x, I'm going to put 30, then plus k. Take 5 the other side, they'll cancel out. So remain with 0 is equal to 2 cos 30 plus k. And then divide both sides by 2, so you just remain with cos 30 plus k being equal to 0. So to remain with 30 plus k, we're going to take the cosine inverse of 0. So that will give you 30 plus k cosine inverse of 0. What do we get? A cosine graph. Starts from here, it goes like that. So cosine inverse of 0 can either be 90 or 270. So mean that 30 plus k is equal to 90 or 30 plus k is equal to 270. Yes, please go on.
So, like for when you reached cos plus 30 and the 2, oh, and the k, I mean,
Mhm.
why didn't you use the double angle identity or something like that? I'm just confused.
Yeah, you could have used it, but you still have to find the cosine inverse. That's more like just a wrong method. Is it okay?
Oh, okay. Yes, okay.
So meaning that k is going to be, if we take 30 the other side, 90 minus 30, that will be 60, or k is equal to 270 minus 30, be 250. Now remember they've said find the smallest value of k, so k is 60. Solve the equation f of x is equal to 4. Take note of the value for k because you need it. So f of x is equal to 4, meaning that where there is f of x, we're going to put 4. So this is going to be 5 plus 2 cos x plus, where there is k, we put 60. So it's supposed to be equal to 4. I take 5 the other side, we are going to have 2 cos x plus 60 being equal to -1. Divide both sides by 2, so that means that cos x plus 60 is going to be equal to -half. I don't want to work with negative things, so I'm going to change. Let x plus 60 be equal to alpha. So I'm going to say cos alpha is equal to +1/2. Take cos the other side, so alpha is going to be cosine inverse of 1/2. Meaning that alpha, we know cosine inverse of 1/2 is 60 degrees. But remember, we're not interested in what? We're not interested in the positive, okay? Because what we are given was negative. So we'll go back. In which quadrant is cos negative? So in which quadrants is cos negative? All students, like second and third. So how do you find angles in the third quadrant? Second quadrant first. It is 108 minus what you have found. And then in the third quadrant, it is 108 plus what you have found. So meaning that alpha is going to be 180 minus 60, 120. And then 180 plus 60, 240. But you know that alpha is x plus 60. So we'll say x plus 60 is equal to 120. So I mean that x is going to give us 60 degrees, or x plus 60 is equal to 240. Meaning that x is going to give us 240 minus 60. What do you get? Is that 180? So these are going to be the values of x. Solve the equation. I hope we are okay. You can actually test if your values are correct. Go here, put 60 here. So it's going to be 60 plus 60, which is 120. So you can say two, you can, if you've got a calculator, you can just punch. Let me try out. 5 plus 2 cos 120. It has given me 4. So that means it's correct. Where? No, these are not values. The alpha is 120 and 240. They are not the answers. You want the values of x. So question number 4. Let's hope, guys, we are understanding. Otherwise, that's a M. Please, if you have got questions, be free to ask. Evaluate the following limits. We have got limit as x approaches to -2 of x squared divided by 3x squared plus 7. So what happens if we substitute 2 directly? Okay, so that is going to be -2 squared divided by 3, -2 squared plus 7. It's going to be 4 divided by -3 squared is 4. I mean -2 squared is 4. 4 times 3 is 12. 12 plus 7, 19. So this is the limit. And then the next one, the limit as x approaches 3. Now for this one, if you substitute direct 3, put 3 here to give you 12. Put 3 here to give you what? 15. Is it? -15 minus 3. Okay, let's say 2 times 3 squared is a 9, not 12. So I thought that was a 2. So 3 squared is a 9. 9 times 2 is 18. And then this one also give us -18. So it will give us 0 in the denominator. So what we are going to have is 0 over 0. And that is what you want to avoid for limits. Because of that, you have to factorize. So on top, we have got a difference of two squares, so that will become x minus 3, and then x plus 3. And then in the denominator, the product is 6, the sum is negative 5. Two factors, 2 and 3, they are supposed to be. Now, if you use 2 and 3, you are not going to get that sum. So you're supposed to get 6 and 1, so that you use a negative 6. So this is going to be 2x squared plus x minus 6x minus 3. So this is going to give us x, 2x plus 1, and then negative 3, 2x plus 1. Means that we're going to have x minus 3, then 2x plus 1. So that this and this cancels. Then you are going to have the limit as x approaches 3. Now we can substitute directly. Where there is 3, we'll put 3 plus 3 in the denominator. We're going to have 2 multiplied by 3 and then plus 1, which is going to give us 6 divided by 7. So this is the limit as x approaches 3 for that one. And then the next one, we have a limit to infinity. Now when you are having limits which are going towards infinity, just look at the highest power on top and the highest power down. If they are the same, just get the coefficient of the highest power on top and the coefficient of the highest power down. You divide, then that's the answer. That would be the limit. So in this case, the highest power on top is x squared, even down is x squared. The coefficient of x squared on top is negative 5, down is 2. So the answer is going to be negative 5 over 2. Now just to show the working, divide everything by the highest power, which is x squared. So we're going to have limit as x approaches infinity. So start 3 divided by x squared, and then you have got 2x divided by x squared to be 2 over x. You have got 5x squared divided by x squared, that will just be 5. Then over 2x squared divided by x squared, that will just be 2. 7 over x squared, that will be x squared. Then substitute where there is x with infinity, that will be 3 over infinity squared plus 2 over infinity minus 5 divided by 2 plus 7 over infinity squared. Now infinity, any number over infinity, infinity squared is 0. So this is 0, this is 0, this is 0. So the answer is negative 5 over 2. Differentiate f of x is equal to 1 over x from the first principle. So we know the first principle, f of x is equal to limit as h approaches 0 of f of x plus h minus f of x divided by h. So this is going to give us limit as h approaches 0. We are going to have 1 over, okay, that is 1 over x. But where there is x, we are going to put x plus h. Then minus f of x. F of x is 1 over x. Then divided by h. And this is going to give us limit as h approaches 0. We'll merge this as a single fraction. Multiply what is on top of the first fraction to what is down. 1 times x, that will be x. Multiply what is on top of the first fraction, that second fraction, that's negative 1 times what's down the first fraction, to give us negative x minus h. Then multiply the two denominators, that will be x squared multiplied by xh, that will be xh. We also have h in the denominator, so I can just put it here instead of writing another denominator. So this and this cancels. This h can cancel with the h there, so we're going to remain with a negative 1. So the answer is going to be, we are going to have limit as h approaches 0, negative 1 divided by x squared plus xh. And then substitute where there is h with 0. So it's going to be negative 1 over x squared. So this is going to be the limit, because if you put 0 here times h, that will be times x, that will be 0. Let f of x be equal to negative 3 cos 2x minus pi for 0 is less than or equal to x, which is less than or equal to 2 pi. Find the amplitude and the phase shift and the period of the function. Starting with the amplitude, which is given as the absolute value or the number in front of the function, that is absolute value of negative 3, so the amplitude is positive 3. And then the phase shift, just equate what is inside to 0. So when you get to equate what is inside there to 0, that is the 2x minus pi being equal to 0, going to find that x is going to be equal to positive pi over 2. Then the period given by 2 pi over b. The b is the number in front of x, which is a 2. So meaning that period is pi. Now I want to sketch the graph f of x. Okay, so first thing first, I'm going to put the phase shift on our function. The phase shift is at pi over 2. So I say this is pi over 2. And then where are we going to end if the period is pi? So all you do is add the phase shift with the period. So pi over 2 plus pi, that is going to give us what? 3 pi over 2. So let me say this is 3 pi over 2. Now we need to divide this region into 4 equal parts. 4 equal parts. Now before I even put this, I'm just going to put the 4 equal parts just in advance. Okay. So from pi over 2, we are going to have this region, going to have also this, going to have also this, 1, 2, and then the last one. So this is going to be now the 3 pi over 2. You need to know that from the period, from the phase shift, when you add the phase shift and the amplitude, you should divide that region into 4 equal parts. Please, you need to know that. So here, these are the equal parts: 1, 2, 3, 4. If you do that, it will be much easier. Now remember, this function is supposed to go as far as 2 pi. That's from what we've been given. So that means I'll have to extend it this side. Okay, so what I'm going to do, I'm going to add where I'm starting with where I'm ending. Pi over 2 plus 3 pi over 2, we are going to get 4 pi over 2, which is just 2 pi. Is that supposed to be it? Okay, pi over 2, that is a phase shift, plus 3 pi over 2, that has given me, yes, that is, since the denominators are the same, we're going to have 4 pi over 2, which is 2 pi. So 2 pi divided by 2, that is going to give us a pi, meaning that the middle of this function is going to be pi. The middle is here. That's a pi. And then also add pi over 2 plus pi. Let's hope I didn't make a mistake when I added pi over 2 here with a pi. Let's see what I'm supposed to get. Okay, this is 2 times pi. 2 pi plus, this is going to be 3 pi over 2. Okay, that is 3 pi over 2, yes. When you add pi over 2 plus pi, that's 3 pi over 2. Now you're supposed to divide this by 2 to find the middles. That is going to be 3 pi over 4. And then also add this pi plus 3 pi over 2. That is going to give us 5 pi over 2. And then divide it by 2. That would be 5 pi over 4. Okay. So now, what I want you to recognize is what's the difference between this one Like for it to come from pi over 2 to 3 pi over 2, what value are you adding? So just subtract this 3 pi over 4 minus pi over 2, which I can also write as 2 pi over 4. So it says pi over 4. Meaning that each half that you're able to see, or each quarter, is pi over 4. That from, if I have pi over 2, for me to go to this one, I'm adding pi over 4. For me to go to this one, I'm adding pi over 4. For me to go to this one, I'm adding pi over 4. To go here, I'm adding pi over 4. So to go to another half here, I'm supposed to add pi over 4. So let's add 3 pi over 2 plus pi over 4. I can make this 6 and make this 4. That is going to be 7 pi over 4. I want to reach at 2 pi. So I'm also going to add again another pi over 4. So 7 pi over 4 plus pi over 4. It is going to give us 8 pi over 4, which is now the 2 pi I want. Okay, up to here, that is going to be 2 pi. Now notice that this is pi over 2. How about if I go behind here? From pi over 2, like if I'm going to the negative, I'm going to be subtracting. Okay, I'm going to be subtracting because if I'm going forward, I'm adding pi over 4. That if I'm going behind, I'm going to be subtracting pi over 4. So remove from pi over 2, remove pi over 4. What are you going to get? You are going to get pi over 4. Like pi over 4 plus pi over 4 is pi over 2. So I just want to remove this because I've seen I need equal region. So pi over 2 minus pi over 4, that will give us pi over 4. Then pi over 4 minus pi over 4, that will give us 0. So now this is where the y-axis is going to be. And remember, the function is supposed to start at pi over 2. Okay, now this is a cosine graph. A cosine graph starts from the maximum or the minimum. The amplitude is 3. So I'm going to go as far as positive 3 and as low as negative 3. Now if you look at this one, the amplitude is negative, or the number in front of the cos is negative, meaning that we're going to start from the minimum. We're going to start from here. So this function is supposed to reach, for you to complete one revolution. Remember when you added the pi over 2, which is where I was starting with the pi, we got 3 pi over 2. So to complete one revolution, we're going to end here. So the middle from pi over 2 to 3 pi over 2, that is pi. That is where we're going to go to the maximum. And then the middle between pi over 2 and pi, that is this one. That's where we're going to cut here. And then also here. So the function is going to move. It goes up, passes there, and then here it tends, comes here, then it goes like this. That means you can say that from, if you have got two lines like this, you are coming from the top to the bottom. From here, from the top to, from the middle to the bottom. That means from where I am, for me to reach here, I'm going to cut it here. And then from here to me, for me to reach 2 pi, I'm going to go to that point there. So it's going to turn again like that. It goes up. And then also in this direction, we're going to pass here and then go there. So it's going to go like that. And then it turns and goes there. So this is the sketch of this graph. If you want to gain all the marks, make sure that you draw it between 0 and 2 pi. And that will be the graph. Now the other question is saying sketch, find the values of x for such that f of x is 3 over 2. 3 over 2 is about, is it 1.5? So that is about just the middle of this function. So if you have sketched it right, like nicely, you can draw a line here. So at every point where you're saying the graph is being cut, those are the values of x, meaning that you're going to have one value of x here, one value of x here, one value of x here, and then another value of x here. But from this graph, it's a sketch we cannot really determine from this graph. That means we have to solve. So now let's solve the equation. F of x is 3 over 2, so I'm going to say negative 3 cos 2x plus pi is equal to 3 over 2. I'll divide both sides by this negative 3 over 2. So dividing both sides by negative 3 is the same as multiplying both sides by negative 1 over 3. If I multiply 1 over 3 by this, it will cancel. Then this 3 will go with this one, so remain with the cos 2x plus pi being equal to negative 1 over 2. But I don't want to deal with negative things, so I'm going to select 2 pi plus x. This is actually 2x plus pi be equal to alpha. So this will become now cosine of alpha being equal to positive 1 over 2. So meaning that alpha is going to be cosine inverse of 1 over 2, and we know cosine inverse of 1 over 2 is 60 degrees. But we want where cosine is negative. So we go, which quadrants is cosine negative? Second and third. How do you find angles in the second? It is 180 minus the angle that you have found. And then in the third, 180 plus the angle that you have found. So alpha is going to give us 120 and alpha is going to give us 240. Remember, what is alpha? Alpha is 2x plus pi. So it's going to be 120 and 2x plus pi. So it's going to be 240. Now here, remember, for us to have pi means that we are not working in degrees, we are working in radians. So convert 120 to radians, convert also 240 to radians. And how do you do that? So just multiply by pi over 180. So 0 goes with a 0, and then you can say 6 into 12. It is 2, 6 into here, that is a 3. So that is 2 pi over 3. So it's going to be 2x is going to be equal to 2 pi over 3. I'm taking the pi the other side, so minus pi. Then the other side we have got 240. Also multiply by pi over 180. 0 also cancels with a 0. What number can we take into? 6 into 24, which is a 4. 6 into 18, 3. So here we're going to have 2x being equal to 4 pi over 3. Take pi the other side, so minus a pi. So this is going to give us 2x being equal to, this is over 1. So I have 2x minus 3 pi, which is negative pi over 3. And then this side we're going to have 2x, that is going to be 4 pi minus 3 pi, which is going to be pi over 3. Now because these are double angles, we can say this is a 2x. To each angle that you have found, add 360 because we are taking 2 revolutions. So to negative pi over 3, add 360. 360 is 2 pi in radians. So we're going to get, so 2x is going to give us negative pi over 3, comma, if we add negative pi over 3 plus 2 pi, that is the same as 2 pi minus pi over 3. So it's going to give us 5 pi over 3. Or we are going to also get 2x being equal to pi over 3. Now we're going to add pi over 3 plus 2 pi, this one which is here. That is going to give us 7 pi over 3. To remain with x, divide now everything. Divide everything by x. I mean by 2. So x is going to be, if you divide this by 2, that would be negative pi over 6. Divide the other one by 2, that is going to be 5 pi over 6. Divide the other one by 2, that is going to be pi over 6. Divide the other one by 2, that is going to be 7 pi over 6. But notice that this value is negative. the range is supposed to be from 0 to positive 2 pi. Negative pi over 6 is about, if you convert this to degrees, just multiply. So negative pi over 6 convert to degrees, multiply by 180 over pi. Pi cancels with pi, 6 into 180. So that's it. So this is about negative 30 degrees, meaning that it is here. So now I want to find the angle starting from the positive axis x-axis in this direction. So that is going to be 330. So to that angle that you have found, just add 2 pi. When you find a negative angle, add 2 pi there. So negative pi over 6 plus 2 pi. That is going to give us, which is the same as 2 pi minus, that is going to give us 11 pi over 6. So instead of writing this, we are going to write 11 pi over 6, which is the positive form. So these are the values of x, given that f of x is 3 over 2.